Hey, we are the Team RoboCup from Gymnasium Langhagen, Germany, and have this year dealt with a performance on the topic of Harry Potter. It is about the first movie and 3 of the tests Harry must pass at the end of the movie to get to the Philosopher's Stone. In doing so, we have endeavored to use as many different sensor and motor skills as possible, which we would now like to explain to you in more detail. Our 4 features selected for evaluation are voice control, the XP network, the connection to the Raspberry Pi, and the use of stepper motors. Before that, however, we want to explain the basic principles of communication between the robots and robots with humans. Here we see the brain of our performance. We call it the controller. It consists of an Arduino Mega connected via I2C to the EV3 bricks of the second room and using serial ports to a voice recognition module and a Raspberry Pi. XP communication is also installed. Voice control works via a library that allows us to train certain commands, which we can then load into our controller and finally compare with the inputs made via a subroutine and its implementation. Let's get to the communication of the Arduino with the Raspberry Pi. This runs serially, similar to the voice control. Via a sub-program, the Arduino serially writes a string which is automatically sent to the Raspberry Pi encoded with ASCII. The Pi can decode the sequences of digits by specifying the serial address of the connection to the Arduino. And then the corresponding image and sound files are searched for, which are displayed by means of Pygame. We'll perceive this as our adaptive background presentation, additionally with cameras. Also important is the XP communication, which can also be controlled via subroutines. XP is a radio-based form of communication that connects all of our robots with each other and thus enables a smooth process. As with our controller, we also use I2C as a communication method between Arduinos and EV3 and other robots at our performance. On the Arduino side, this works via a library and a tag that we send to the EV3. The EV3 can then read out the sensor port. For this purpose, a separate function is available in the EV3 library of Small Basic. Harry has to flee from Fluffy in the first room. An infrared sensor is used to check whether the beacon moved by the second room is on the left, right, or straight in front of Harry. In the appropriate direction, Harry then moves with his mechanism wheels, which enable him to drive sideways as well. Fluffy uses a pixie cam to recognize Harry's position and move his head accordingly. The Arduino uses the data from the pixie cam to determine whether Harry is in the middle, left or right, which it then sends to the EV3 using I2C. This then results in movements of the head, so Fluffy is always fixated on Harry. This is the second room. Harry flies to the various keys via an engine construction. Previously, the controller randomly decided which key in this run would be the right one. The RFID reader on Harry's back verifies the ID of the key and sends this data via XP to the controller, which then denies or confirms the correctness in the direction of the EV3. Either the next key is flown to in here or Harry returns to the starting position. The third room revolves around a chess game that Harry plays and where he has to checkmate his opponent in order to win. For this purpose, the controller sends signals via XP to the chess robot, which is also an Arduino. These instructions include the current and the future position of the chess piece to be drawn. The chess robot translates these signals into movement instructions, taking into account its current position. With stepper motors, which are controlled with the help of motor drivers, we ensure a precise and fast movement of the chess pieces. In addition, a linear drive is used to bring the magnets above and below the plate into reach, so that they can attract each other and thus the figure can be pulled along.